So here we go. So welcome, guys. Thank you so much. And just before we get started, I need to remind us or ourselves that we are writing the minor tests this week on Friday. The details are on Moodle. So please take a note. We've given you a breakdown of what's to be tested. And interestingly enough, we restricted to limits and continuity. So the test looks pretty straightforward, nothing difficult, together with hyperbolic functions. All right, I'll talk about that a little later, and I'll give you a few examples from past exam papers so that you can start working on that as well. All right, test is pretty straightforward, but like I said, this is a great chance to actually do very well in the minors because this is test 3. We take 2 best of the 3 minor tests, and then we also take your 2 major tests. All right, both major tests. So that becomes very important that we do extremely well. So let's get started. I want to continue with the derivative differentiation. Right? So I want to teach you the chain rule today and a few new rules that you've not seen in school, which is the product rule, the quotient rule, and then of course the chain rule. And Khadi, you got your hand up? You had a question?
Yes, sir. I wanted to ask when are we going to get our marks for test one, major test one?
Yeah. So basically, the marks have already been sent to the secretary, as I said to you previously. She's got if I get the wrong, 3,200 marks to capture. So our class is one of those 3,200. I'm not sure at which point she is, but the last, I think I mentioned to you, she was capturing that almost 1,000 marks for Maths 2. And then, of course, the other courses as well. I'll check with her and see at which group she is at the moment, but she'll definitely be capturing. So this is one person sitting there typing every single mark from an Excel file. So it takes a lot of work, but I'm hoping that we have faith in her and that she will get our marks up. All right, but I'll keep you guys informed. In fact, that's a very good question. All right, so let's get started. I'll share my screen. Let's take away that scary video of the scary man on your screen. So I'll take that away. Gone. Now we all good, and I'll share my screen. So the first part would look remember we introduced the idea of the derivative. We looked at the derivative from first principles. And now I'm looking at this idea of ddx. I'm just reminding you of the sort of notation that we've seen. We've seen this in school. When we say ddx of x squared, we know it's 2x, right? The power rule. But what I want to do now is introduce you to more general rules, which we need in our tests and exams, and of course in life itself. So let's get through it. But today I really want to introduce you to one of the most powerful rules in mathematics, and that is the chain rule. All right, so be familiar, right? In school, we know what ddx means, we know what f prime of x means, and somewhere in school, someone decided, well, they're going to introduce this notation as well. So when you see d subscript x or d subscript y, it means the same, ddx. Okay, so don't get confused. Or f prime of x, right? So if you look here, the first rule that you've learned, or the only rule you've learned in school was the power rule, right? So if you're taking ddx of x raised to the power n or ddy of y raised to the power n, we're familiar with this. Drop the n to the front and subtract 1 from the power or the index. All right. So this is someone's in the background there. Okay. So people are joining. That's great. Excellent. As you join, please mute your mics so that nobody gets disturbed. And like I said to everybody, good morning. And we just going through all the various rules. Okay. So now, these rules you have been using in school, the sum and difference rule. So if you've got 2 functions, and if I'm differentiating it, the sum of 2, so ddx of, say, 2 functions, f of x and g of x, of course, we're assuming that these functions are differentiable. Then, if you have a look, it becomes ddx of f of x plus ddx of g of x. I'll give you an example. So if I had to ask you, what is ddx of x squared plus x cubed? Now, you can write this as yes question of x cubed, and then what's your final answer? It'll be 2x plus 3x squared. Okay, so the same thing would apply to the difference. If you had a minus sign, you're going to get that there. So this rule is pretty straightforward. We use this in metric and nothing difficult. Now, here you got to pay careful attention. All right. This is probably going to be new to most of you here because we haven't looked at this sort of rule, say, in school. But I'm gonna apply this rule with a very silly example. So, for example, I'm going to ask you the following: what is ddx? Let's say we got the product of two functions, x times x squared. But you'll say, but this is pretty stupid because is it not ddx of x cubed, which is what? Anybody? What is ddx of x cubed?
3x squared.
It's 3x squared, correct. Now, if we apply this rule, watch this. If I'm going to apply the rule, the derivative of the product is really nothing more than keep the first, you got to choose, there are two functions. You're going to keep one constant, differentiate the other, and then plus. So there are two terms. So let's see if I can apply this. So we can go ddx of x times x squared. Watch this. I'm going to keep the x squared constant. Call that the second function in inverted commas. And I'm going to differentiate the first function. So that is ddx of x plus I keep the first function constant and I differentiate the second one. So what do we get? X squared. ddx of x we know is 1 plus x, and ddx of x squared is 2x. And for sure, as God made little apples, the answer is 3x squared, which is what we got here. You see? And you might say, but that's pretty straightforward. Yes, it is straightforward. But what I'm going to do now, just shortly, I'm going to introduce you to the derivative of the exponential function, the derivative of the trig functions, derivative of the log function, ln function, and the hyperbolic functions. And that's what makes this section very interesting. Okay. So now, if we got the product rule, surely we must have the quotient rule. So let's see what that looks like. Okay, there's more on the product rule over here. That's pretty straightforward. So I'll give you another example. Yeah, you can use. So what is ddx of square root of x times, let's make it x cubed, right? So what we can do is write it like this. Watch. Keep this guy constant, differentiate the first guy, plus, right? Keep the first guy constant, differentiate the second guy. And from there, you can easily differentiate. Remember, recall that square root of x is the same as x to the power half. So you can then differentiate this thing. So this becomes x cubed. And what is ddx of root x? It's a half x to the minus half because I've got to subtract 1 from there. Plus root x, what is the derivative of x cubed? 3x squared. I'll leave you to simplify that, and your answer would be a function of x. Right. So the product rule is straightforward. Now, let me introduce you to another rule called the quotient rule. Aibo, quotient rule. Now, this one looks a bit. Okay. Does someone got a question? No? Okay. So there's the quotient, f
Hello.
over g, where g is. Hello? Hi? You have a question? Nope. So g is not equal to 0, right? Of course, if we had g equal to 0, we're going to have a probability dividing by 0. So this rule is slightly more interesting. The derivative of a quotient, look, keep the denominator constant, differentiate the numerator, then it's a minus sign, and then you got f, keep the first constant and differentiate the second, but all over g squared. Okay, so if I had to go, let's write this out, ddx, let's just take something, x cubed over x. Hey, you're going to tell me, but that's silly because this is ddx of what? What's x cubed over x? It's x squared, and the derivative we know is 2x. Okay, but let's treat this as a quotient. So what is ddx over x cubed over x? where we have treat them as two separate functions. The rule says keep the bottom guy constant, differentiate the top guy, minus keep the top guy constant, differentiate the bottom guy, all over the bottom guy, all squared. So this becomes x. What is ddx of x cubed? That is 3x squared. Minus what is ddx of x? That's 1 all over x squared. Okay, so sorry, this should be x cubed. So this becomes 3x squared minus x squared, cubed, 3x cubed all over x squared. And look at that, we get exactly 2x. So we can take this very complicated rule, and you might say, but why don't we do it the way we did it in purple? It's so simple. And the reason why it's simple is because the forms of these functions are pretty straightforward. But what if I asked you to differentiate ln x over sin x? You see? So you can't do that. So what we have to do now is introduce you to the basic derivatives. And I think this is the best way to go. So here you got to pay careful attention to these special derivatives. Okay. And I'm going to start slightly differently because I'm going to start off with the derivative of e to the x. And this one is the easiest one. Guys, pay careful attention to this now. So I forgot y equals to e to the x. So if I want dy dx is going to be what? Does anyone know? Has anyone read about this? What's the derivative of e to the x? That's
X e
right.
to the power x
You'd say x e to the x. Yeah, that's a good try. Someone said e to the x,
minus
which is
1.
very good. Someone says -1. That's good. You're trying. So the
Yes.
derivative of e to the x is very interesting. The derivative of the exponential function, the natural exponential function, is actually the exponential function, e to the x. So the derivative of e to the x, guys, is just e to the x. Right? I don't think anyone's going to have a problem remembering that, right? The derivative of e to the x is e to the x. And that's something that you need to keep in mind. Okay? So that's my starting point. Now, let me introduce you to the derivative of the trig functions.
Why?
Right? And hello? Hi?
Why?
What do you mean why? Right?
Why it is e to the x?
Oh, that's basically it. That's its natural. When we're doing L'Hopital's rule, I'll actually prove that. I'll actually prove this, that the derivative of e to the x is e to the x. The derivative of this function is the function in itself. Okay, so we'll be looking at indeterminate forms. We'll be looking at limits of indeterminate forms, and then from there we'll prove that the derivative of e to the x is e to the x. In fact, you can actually prove this using this here. Remember, y prime is the limit of f of x plus h minus f of x all over h, as h tends to 0, where f of x now is e to the x. So we're going to use this idea of the derivative to show that it's e to the x. Okay, so just keep that in mind, but this is what I want you to know for now, because I'm going to bring in the chain rule shortly, and that's going to make things interesting. All right, that's a good question you ask. Okay, so now here is where it gets interesting. Derivatives
Sorry,
of, yes,
sorry, sir.
yes, I'm
Sir,
listening. Yep.
let's say we have a function of e to the power of 2x. What would be the derivative of that function?
Yes, we're coming to that now. It's called the chain rule. I don't want to introduce that just yet. Coming to that just now. I want to
Okay,
introduce you
thanks.
to the, I'm introducing you to the base derivatives, and then we'll be bringing questions like e to the kx, e to the minus 2x, e to the sine x. Those are the sort of things. But let's get the base derivatives first, and then we'll move on. Good question as well. So let's look at y equals to sine x. The derivative of this function is cos x. So the derivative of sine x is cos x. Okay, so now watch. If I got y equals to cos x, then the derivative of cos x, here you got to be careful, is minus sine x. And the third one, if y is equal to tan x, then the derivative of tan x, does anyone know? Maybe you read?
Six squared x.
Yes, 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 that's correct. So these are the three fundamentals that you need to know, right? Or what we call the base derivatives. Sorry, guys, 1 second. There's someone at the door, so I have to pause.
So if someone
Okay, guys, I'm back and people are joining, which is great. Are there any questions before I move on from here? Anything, guys? All clear? All good? Now, I want you to, if you grab a piece of paper, I want you to work this out for me. Can we prove that if y is equal to tan x, its derivative is sec squared x, using the quotient rule? Anybody? What do you think? Prove that y equal to tan of x, y prime is x squared of x. Can you prove that? How would we do that? Anyone? Come think about what is tan x? What is tan x? I always told you, can we write tan x as what? Anybody?
Sine
Sine
x
x
over cos
That's
x.
Sine x
right.
over cos x.
That's right. It's sine x over cos x. So now you pull in what? If you got y is equal to f over g, right? Then y prime is g f prime minus f g prime all over g squared. Let's apply that formula. If you've got a piece of paper, start writing. Let's see if you can get something out of it. Right? And I will write down my solution. So there's your f. There's your f here. This is f and this is g. So we're going to go g, you keep constant, but the derivative of sine x, I told you, is cos x, right? And then you got keep the minus sign, and the derivative of cos x is minus sine x, and all over cos squared x. And for sure, as God made little apples, you got cos squared x plus sine squared x all over cos squared x. Now, anyone, what's the numerator equal to? What's the numerator equal? It's 1. That's perfect. And what is 1 over cos squared x, anyone?
sec square.
There we go. We can all go home. Thank you. Bye. You see? It's
Thank you very
easy.
much.
It's not. I'm not finished yet. But I'm saying it's quite easy, right? It's not difficult.
Is this
So
genius?
we try. Yeah. This is the sort of stuff that we're going to see in major tests too. And remember what I said. We want 100% pass rate in our class, irrespective of what happens. 100%. This is what I want. We need to show DUT that we engineers can pass mathematics, not just pass, but do extremely well as well. Okay, because they always ask me, so why are the engineers always getting around 50%? And I'm saying, well, they haven't seen me lecture yet. So come guys, let's get them let's prove them wrong when they think that we're only going to get a 50% pass rate. That's nonsense. So this you got to keep in mind. And then, of course, a very special one for me is this one here, y equals to ln of x. The derivative of ln of x turns out to be 1 over x. That's it. Right? So if you differentiate ln x, you get 1 over x. Right, questions, anyone? Now, now that we have these, we also have the following. What about the hyperbolic functions? I'm just giving you all of them, and then we'll start applying these rules. Hyperbolic functions. So I've got y equals to sine x. The derivative of this is cos x. Oops. Cos x. Right? Now, guys, can we prove this? Can anyone in class prove this? If y sine x, y prime is cos x. How would you prove it? Just give me an idea. How would you prove it? What will you use?
The product rule.
Product rule, okay. Or okay, firstly you'll say let's write down the definition. You agree that we have to write the definition down first, like that, right? Because that's what sine x is. Now, if I differentiate this thing, what are we going to get? The top, if I differentiate, I'll get e to the x. Now here, there's a minus sign. You have to be very careful. When you differentiate that, I'm coming to this now. It becomes minus into minus 1 e to the minus x. And that turns out to be e to the x plus e to the minus x over 2, which is cos x. But I'm going to show you how to prove that shortly. Okay. And then the second one is if you got y equal to cos x. Now think of cos x, it's e to the x plus e to the minus x. So the derivative of that is not minus, but plus sine of x. Okay, so what do we need to keep in mind, like a little data sheet in our minds? We need this, put it on a sheet of paper, stick it on your wall. We need that, and that should live in your minds. We need that, and then we need the cos and the sine, right? We'll come to tang and cot shortly, but these are the fundamental functions we need. So in the exams, this is what we're going to ask. So for example, anybody, I got a function f of x or y equals to, let's say, ln of t times e to the t. Ln of t times e to the t. I want the derivative y prime, which means I want dy
1 over t.
Yes.
1 over t e plus e to the power t 1 over t.
Oh, very nice, very nice. Okay, so remember, take that to be a function f, take that to be a function g. So dy dt, which you call y prime, you will keep this guy constant. You'll differentiate the first function, plus keep the first function constant, differentiate that, right? So the first function is e to the t. Sorry, second function e to t. The derivative of ln t, as you said, is 1 over t, plus if f is ln t, keep ln t constant, and if you differentiate e to the t, you get e to the t. So you can tidy up and say e to the t into. So these are the type of things we're going to ask you in the exams. We're going to mix these things up and then ask you to differentiate these. So that's the product rule. I can even ask you the quotient rule. So for example, sorry, if you're taking this down, I'm recording it. So I'll put this up as a video you can watch. So for example, if you want to look at something like this, let's look at the quotient rule because that really bugs people. Find y prime if y is equal to, give me something interesting. Oh yeah, ln t all over sine t, right? Now remember what the quotient rule tells you. Quotient rule tells you if you've got a function y is f over g, then y prime is g f prime minus f g prime all over g squared. So there's my f, there's my g, and now I want to differentiate this thing. So y prime, I'll keep the bottom one constant. I'll differentiate ln t, which is 1 over t, and then go minus, keep my ln t constant, and differentiate sine t, which is cos t, and then all over sine squared t. You guys happy with that? Everybody? Which is what they want. Okay, so we'll give you a bit more. Now, this is where it really gets interesting. And someone asked that question early on, and I think it's a brilliant question you asked. I like that. And that is it always that simple? Because what if they ask me something like, and let me just write this out. I think fundamentally this is the most important rule in mathematics. I can't even spell chain rule. The chain rule. Right? What is this? It's actually the derivative of composite functions. So for example, right, I know that ddx of e to the x is e to the x. So the question now is, what is ddx? As someone asked before, of e to the 2x. Anybody? Any thoughts? Anybody? Any? What do you think the answer is going to be? Most likely be.
I think so.
Yep.
The answer would be 2 times
Yes.
e. That's by
To the.
2x.
That's right. That is
To the power of
absolutely
2x.
correct. That's right. That's exactly what it is. Now, guys, if you look at your textbooks, you watch other YouTube videos, they're going to give you a long story on how to get this. Here's my version of it. All right. We know the ddx of e to the x is e to the x. So watch how I say it. It goes like this. The derivative of e to the 2x. Read it like this. So you ask yourself, what is the inner function? What is the innermost function? The inner function is 2x. So you would differentiate 2x first. If I had to differentiate 2x, I'm going to get 2. Then what is the derivative of e to the something? The derivative of e to the something is e to the something. And there's your answer. Right? So the chain rule involves you differentiating from the inside going out. I'll give you another example. Right? What is ddx of sine of 3x? So you look inside, you see right now, if I want to evaluate sine of 3x, I have to start here. I don't start with the sine first, I start with the inner function. So what is the derivative of 3x, anybody? What's the derivative of 3x? Don't overthink it, just the inner function.
3.
What is the derivative? It's 3, right? What is the derivative of sine of something? What's the derivative of sine? It's
Minus
cos.
cos
It's
3x.
cause.
Let's go back. There's it here. The derivative of sine of something is cos of that something. So that's all you write down. The derivative of sine of something is cos of that something, which was 3x. And there's your answer. Boom, walk away. You see? So let's try another one. But this time I'm going to put a bit of a twist in it. What is ddx of cos of e to the x? What's the derivative of cos of e to the x? Think carefully. Look at
Minus
the inner
sine
function.
e to the x.
Right, you said minus sine e to the x. Okay, okay. Anything else? Start with the inner function. Inner function is e to the x. So what's the derivative of e to the x?
E to the x.
That's right.
Minus
E to the x.
E to the x sine E to the
Yeah, correct, correct. So we start here and we ask, what is the derivative of the inner function? Derivative of e to the x is e to the x.
E to the
Then you
x.
start with the outside function. What is the derivative of cos of something? It's minus sine of that thing. And so your answer, as you said, and that's your answer. Boom. And you walk away. It's straightforward. It's simple. Okay. You getting the idea, guys? Okay, try this one. Try this one for me. If I give you y equals to ln, ln of sine of e to the x, just for fun. Give me the derivative of this. Write it down somewhere. Start with the inside function, not the outside. You must always start from the inside going out. Start from the inside and then go out. Right, guys, think about it and give me an answer. Write it out, write it out. Anyone's got an answer? Anyone wants to shout out an answer? This will be worth 2 marks in the exams, by the way.
2 marks.
Yeah, 2 marks, 2 marks.
Sir,
Yes,
can I try, please?
sure, please try. Let's go ahead.
I, I think the answer will be e to the x, e raised by x
Right, e to the x. Okay,
times
let's see. Right, so you're saying y prime. So your derivative of e to the x is e to the x times.
1 over x.
Okay, but what about the sign? You missed the sign out.
Oh, it's cos
What's it? Yeah, it'll be cos of e to the x times
of e to the x is
times.
1
Yeah.
over x.
Would it be 1 over x, or what is ln of something? This is the something. It'll be 1 over the something, right?
Oh, yes.
That's what. So
Yes.
it'll be sine of e to the x like that. You see? So, and someone's looking at this saying, hey, but hang on, that is nothing more than cot of e to the x. So let's do this slowly. Close, very good attempt. So you got y is equal to ln, watch this guys, of sine of e to the x. So we start with the inside. The inside function is e to the x. The derivative of e to the x is e to the x. The next function is sine. The derivative of sine of something is cos of that something. That's how you read it. And then the derivative of ln of something is 1 over that something. Does that make sense?
Yes.
All right, so now I'm going to give you another one. These things are not in the textbook. These are ones that's in my mind, in my very disturbed mind. So let's go. Y is equal to, let's see whether you get this one. Okay, let's try something like this. E to the minus sine of e to the x. Beautiful. What's the answer to this one? Okay. Write it down, write it down, write it down. Don't think, write it down. Instead of thinking about it in your head, write it down. It becomes easier. Look at the innermost function. The innermost function is e to the x. What's the derivative of e to the x? It is
E to
e to the x. That's right. Now, what's the derivative of minus sine of something? What's the derivative of minus sine of something?
It's minus cos of.
That's right. It's minus cos of something. You got to use that word something. Then, what is the derivative of e to the something? What's the derivative of
E to the
e?
something.
That's right.
E to the something.
That's it, guys. And we're home. That's your answer. They can give you the most complicated function. I would challenge anyone. You can go to YouTube right now and go on YouTube the uh, the chain rule and see how difficult they teach it. They teach it in the most difficult way. This is the easiest, simplest way of getting it, and you'll never get it wrong. Trust me. This is the chain rule, guys. But you are not going to go anywhere if you don't know the basics. The basics would be know your trig functions, know your ln, know your e to the x, and know your hyperbolic functions. Those are your base. And from there, you can fly. I'll give you something as simple as this. Trust me, people actually get this wrong in second year. So for example, if I gave you y is equal to, say, e to the minus 3t squared. E to the minus 3t squared. What is dy dt equal to? Anybody? Think carefully. This is the inner function. So what's the derivative of minus 3t squared? What's the derivative of minus 3t squared?
Minus
Minus
6.
It's
T.
minus, yeah, it's minus
6.
6t. That's right. Don't overthink it. Now, what is e to the something?
E to
Derivative
the
of e to the
something.
something.
E
That's
to the
it.
something.
Thank you. That's it. Yeah. And then we all go home. It's as easy as that. Don't overthink it, right? So if I give you another one, y is equal to, now watch this one. You have to be careful. Sine of ln squared of t squared. I'm really messing around with your heads now, but I want to make it as difficult as possible. Write your answer down and I'll put mine. Let's see whether we get it right. Let's compare answers. Sine of ln squared of t squared. So it's sine of ln squared of t squared. Start off with a very basic question. What is the innermost function? And then work your way out. That's all.
Uh,
Right, let's go. Yep. Anyone wants to give me an answer? Inner function is what?
is one.
Where do you?
It's 1 over
No,
t ln t
no, no,
plus
no, no. What is the innermost function? It's t squared, right?
It's T squared.
That's
Two T.
right. Right. So you differentiate t. Yes, you get 2t. Now, what is the derivative of watch? Now it's ln squared of t squared. It's ln squared of something. So what's the derivative of ln squared of something?
1 over t
1 over
squared.
t squared.
Right. It's 1 over t squared because that's ln of something, 1 over t squared. But what about ln squared? If I differentiate ln squared, what do I get? Because there's two things happening, right? You're taking ln of something squared, ln of t squared, you get 1 over t squared. I'm happy with that. But what about ln of something squared? If ln squared, would you not say that is 2 ln of t squared
It
for the
is.
squared part? Yeah. So be careful, right? So if you've got ln squared, you land up with 2 ln squared. Now, what is the derivative of sine of something?
It's it's cos.
cos
Yes,
of
that's
something.
it. Cos of ln squared t squared. And there's your final answer. It looks very complicated, but it's not. You can simplify this as well. But I think the issue here is the ln squared. See, if I got a function u equal to ln squared of t. Remember, what is that? That is ln of t all squared. This is a nice way of writing it, guys. So this would be, what's the inner function? Derivative, which means inside function would be derivative is 1 over t, and the derivative of something squared, think about it, the derivative of something squared is 2 times that something. And there's your answer there. You see? So you write it like that. Let me explain again, right? If I got a function y equals, let's do this. Let's make it ln cubed of t squared. You tell me what the derivative of that is.
It's 1 over t squared times
Yeah,
3 ln t squared.
ln squared t squared. Yeah, because you can write this as ln of excellent t squared all cubed. Now the inner function is t squared. Sorry, the inner function is t squared. So if you differentiate t squared, I will get 2t. That's the first thing. Then watch. Now you got the derivative of ln of something. The derivative of ln of something is ln of that something. Right? We all agreed with that. Now the derivative of something cubed. The derivative of something cubed, as you said, was 3 times that something squared. I don't know if that makes sense. It's 2t. Oh, hang on. Sorry. This one, you're right. The red, the derivative of ln is 1 over t squared. I think you can ask me that, right? The derivative of ln of something is 1 over t squared. That's it. There we go. You happy with that? Think carefully about that one. Right? So where does the 2t come from? It comes from the derivative of t squared. Where does a 1 over t squared come from? It comes from the derivative of ln. And where does the green, what happened here? Where does the green part come from? It comes from ln t squared all cubed. So if something is all cubed, then it's 3 times that something squared. So spend a moment on that, think about that, and see whether you agree with that part there. Yeah. I don't expect you to get this right. As I was in first year, when I saw this the first day, I'm thinking, hey, what is happening over here? But as you do more problems, but they didn't teach it to me like this. And you see textbooks as well, they teach it in a very complicated way. I'm surprised no one asked me why it's called the chain rule. Anybody? What do you think is called? Wait, where's the chain here? Interesting, isn't it? Why is this thing called the chain rule? And it's a bit weird. Let me show you, but you don't have to do it this way. If you want to do it, you can do it this way, but I'm just showing you why it's called the chain rule. I think the method I'm showing you is very, very powerful and it works quite nicely. But why is it called the chain rule? You don't need to know this, but you never know. Someone's going to ask you, why is it called the chain rule? Firstly, it works for composite functions. So it's a function of a function. So for example, if I got f of x is equal to, right? Let's say sine of e to the t. I want the derivative of that. Then the rule says let u equal to e to the t. Then watch. du dt we know is e to the t. So this function now becomes a function of u because e to the t is now u. So if I want f prime, which is df dx, right, watch the chain building up now. So it's df du. du dx. Oh, sorry, not sorry, df dt. So df du is cos u, and du dt is e to the t. They didn't give you u, you put the u in there, so that becomes e to the t. Do you see how confusing? So there's the chain. So if you have more functions, you'd build up a long, long chain. That's why it's called a chain rule. A function of a function of a function of a function. So you'll see textbooks giving, I feel this is nonsense. For me, this would work like this. Watch. I don't have to put all of this in here. If they gave me to, this is f of t, by the way. So if they gave me f of t is equal to sine of e to the t. Watch how I do this. So f prime, which is df dt, in a function is e to the t. What's the derivative of e to the t? E to the t. Then next function, what's the derivative of sine of something? It is cos of that something. In one line, I get the same answer. Done, and I walk away. I don't waste my time over this nonsense here. Okay? And my method always works.
Masterpiece.
It's a masterpiece, yes. Thank you. And if you go to YouTube, go to my YouTube channel, please guys, like the channel to make a plan there. You'll see the chain rule I put up about 5 years ago when I was teaching this course. People liked it and they did well. They passed. Didn't have to go through this. Didn't have to. All right, so let's try one more just for fun. This is getting so exciting. What could it be? Right now, try this out. Okay, so now I'm going to give you a function and I want you to differentiate this function for me. Let's call it f of t. Change the variable. Right, so I'm going to go cosh of cos of sine squared of len of e to the 2t. Oy, oy, oy. I made this even more difficult for myself. Right, find df dt. Cosh of cos of sine squared of len of e to the 2t. Let's see who comes up with the answer. Take your time. And then gonna ask all your friends in engineering, even second year and third year, if they can do this problem. Let's see what they tell you. But let's do it ourselves first. Anyone's got an answer? This one will be worth 2 marks. This will be worth 2 marks. Right, so are we ready to work or you need a minute or two, guys? More? Do you need more time?
Just
A little bit.
more.
Okay, I'll give you another minute. All right, and I'm also going to color code this so you'll know exactly where the derivative comes from. Right, I'm going to do this slowly, so pay careful attention. Can I get started, guys? Yeah. Right, so let's start with the red, the innermost function. What's the derivative of 2t? Anybody? Derivative of 2t?
2.
Right, so I'm going to put the 2 in red. Now, what is the derivative of e to the something?
E to the something.
Right, it's e to that thing, right? E to the something. Then what is the derivative of ln of something?
It's 1 over something.
Something.
Right, it's 1 over e to the 2t. Right, now watch this one. You have to be careful here. Because this sine squared, we deal with the sine first and then we square it. So what's the derivative of sine of something?
Cos of something.
Cos of something.
Right, it's cos of ln of e to the 2t. Very good. Now we still got to be careful because I still got to worry about the square. So what's the derivative of something squared? What's the derivative of something squared? Like what's the derivative of x squared? We know is 2x. So what's the
2x.
derivative? Yeah, it's 2 times that something, isn't it?
Yes.
Like that. Then times, I'm running out of color here now. What's the derivative of cos of something? What's the derivative of cos of something?
Sine, negative sign of something.
Minus.
Yes, it's minus
Sine.
sine of that something. One, two, three, 1, 2, 3. Yeah. And finally, we're almost there. What's the derivative of cos of something?
Minus sine.
Would it be
Minus
minus or plus?
Minus sign of something.
No, there's no minus sign. For hyperbolic, it's plus.
It's plus
If you
sine of
go,
something. Yes.
yeah, and that's it. And that's your answer, guys. Game over. You can simplify it, for example. You can cancel that with that. You can simplify that thing, but we're not interested. We've done it. It's done and dusted. But that's your answer. So you can take the most complicated function in the world and you can always get the answer right. And this is what they try to trick you in the school. Ayanda, you had your hand up. You had a question? Anybody? You see how easy this is, right? So they tell you the chain rule is going to be difficult because now we're going to reverse this. Next semester, we're going to integrate. We're still going to use this chain rule as well. So we might as well learn it now and make sure we understand it. We're never going to ask a question as this tough. But what I'm saying is we get questions like this and then people make mistakes. Simple thing like y equals to, and they say uh, um, e to the minus uh, ln t. Simple thing like this, right? E to the minus ln t. What is the derivative of e to the minus ln t? So people struggle with this, but the thing is, you could ask yourself, y prime, what is it? So don't overthink it. It's minus ln t. Let's start there. What's the derivative of minus ln t? Well, don't even go there. What's the derivative of ln t? It's 1 over t, but there's a minus sign sitting in front, so it becomes minus 1 over t. Then you ask yourself, what is the derivative of e to the something? Well, it's e to the minus ln t, and there's your answer. But you can make this look very beautiful, isn't it? E to the minus ln t is the same as e to the ln of 1 over t. Hey, but hang on, when e meets ln, we know what happens, right? They dissolve, so the final answer is minus 1 over t squared. Beautiful. That's your homework. Check that out. E to the minus 1 over t squared.
Beautiful.
That's your yeah, it is. It is. It is. Yeah, really remarkable stuff. So there's beauty in mathematics. But I was just sitting in the conference right now and I realized that people were asking questions. Yeah, so what? You solved for X, you did this, you did that. What does it mean in terms of physics? And Yeah, so that's basically it. So question, guys? Any questions?
You may proceed.
Okay, great. So guys, so this was what I wanted to do today, and I want you to be motivated. I want you to be excited. But I'm also thinking, and I got my hand on the trigger for test number 3, minor test 3. So I was looking at some past exam papers and talking to some students and stuff and said, hey, you know what, let's get some ideas. So guys, I want to give you a few questions to work out. So these questions, I'm not going to discuss them now. I want you to work through these questions yourselves, produce the answer. You can discuss it amongst yourselves, but do it yourself first, and then we will discuss it on Friday. Would that be a good idea if I share these questions with you? All right. I think this will be very, very useful. It'll be very, very useful for Friday's test. They're taken from past exam papers. So let's have a look and see whether we can. So if you, I just want to go through each one of them, and then you make a note of it. So it's minor test 3 revision. There's it here. So I pulled up from the archive. This is from the archive now. Some old question. You don't have to take it down. I'm going to go through each slide so that it gets recorded, and then upload the recording, then you work through it, right? So the first one is direct substitution. Now you see, the problem with this question over here, sometimes students get confused with the fractional powers, but also the thing is, we're always looking for nice answers. Like the limit of this thing is 4, or the limit, but the limit could be 2,6735. Nothing wrong with that. So if you substitute -5 in there and it works out, that's cool. That'll be your answer. But if you end up with a 0 over 0, infinity over infinity, indeterminate form, or infinity minus infinity, that's an issue. So direct substitution, you get an answer which is finite, whether it's negative or positive, but real, we cool with that, right? So this, try it out. I'm just talking to each of the questions. Then we got these indeterminate forms. So for example, if I put x equal to -1 here, direct substitution, if you check this out, it's going to give me 0 over 0. So when you have a 0 over 0, now what is the next thing you do, guys? If you get a 0 over 0, what would you do with this problem here?
Have to kill yourself.
Kill yourself. Hey, no, man, please. We have a greater purpose here. Remember, we will qualify as engineers. We could rationalize, but what about, I think you mean factorize. Yes, factorize. If you factorize this thing here, you'll see you'll have an x plus 1 coming up at the top. You can cancel x plus 1, and then you can put x equal to -1. So firstly, you check by direct substitution. If it gives you a problem like 0 over 0, infinity over infinity, step number 2, see, check if you can factorize. If you can factorize, simplify, and then do a direct substitution, you should be fine, right? That's the other type that one could ask. This one I sort of discussed in class here, but this is an interesting one, because if x tends to infinity, e to the infinities, so you got infinity over infinity, top and bottom. So normally when you do that, then you look at this thing and say, right now, you can factorize and see if it factorizes. You can let k equal to e to the x, but this is not going to factorize. What would you do if you're faced with something like this? This is an old exam paper. I think it's 2022.
Divide with the highest power.
Divide by the highest power, correct. You divide top and bottom by e to the 2x. So by doing that, can anyone give me the answer immediately? What's the answer? As x tends to infinity, what's the answer? Without doing anything, can you give me the answer?
-1.
-1, no. 3, no. How about 1 over 2? How about 1 over 2? Yeah, who agrees is 1 over 2?
Oh yes, it's 1/2.
Yeah, you divide by the highest power, so you're going to get that gone, you're getting 1, and these guys are going to go to 0, right? So just double check that. We will discuss it on Friday, right? And then this one, if you see again, how would you do this? Would you rationalize first, or would you do a direct substitution first?
Direct substitution.
Correct. So if you put a direct substitution, what do you get?
Undefined.
Yes, you get a 0 over 0, right? Indeterminate. Then you rationalize, isn't it? Multiplying top and bottom by the root of x plus 22 plus 5 over the root of x plus 22 plus 5. I'm going to leave you to do that. Let's see what you come up with there. So direct substitution first, always. That's our rule. If it's not working out, then you do factorization. Not working out, then you do something like rationalization. Lovely. Then, moving from limits, of course, there would be other limits. Like if I asked you to solve this question here, cot theta equals to 1. What is this all about? Like how would you solve this? You can use ChatGPT, but hey, please don't. We'll know. How would you do this? Yeah, what is cot? Cot is
1 over tan.
1 over tan, which is cos theta over sinh theta equals to 1. But then, how are you going to solve that? Well, you can say cos theta is equal to sine theta. And then from there, where are you going to go? I think you know the answer.
Function.
Yes, these are hyperbolic functions, but you go to the definition. Correct. You go to the definition. E to the theta minus e to the minus theta all over 2. The 2's will cancel. You get e to the theta plus e to the minus theta equals to. You get this, guys? That will cancel. That come. Hey, no, you're not going to get 0. You get 2e to the minus theta equals to 0. So anyone wants the answer? Is there an answer? Let's put it that way.
Lin, this is interesting. So Lin.
Yeah, so you go e to the minus theta is equal to 0 over 2, which is 0. You take ln on both sides, but you see there's a problem, is it? What is ln of 0? It's undefined. So there's no solution to this. Yes, there's no solution, but I knew there was no solution. But what I wanted was the method. You see how I changed? I changed to the basics, and then I tried to solve. This is important. So now someone asked me a question like this in class the other day, and it was quite interesting. We know there's an e to the x and there's an e to the minus x. This was in test number, it was in major 1, in fact, solving equations, right? And we know that if we have an e to the x and we have an e to the minus x, then what we do is we let k equal to e to the x. Is that correct? Anybody?
Yes.
We let k equal to e to the
Yes.
x. So what happens to that question then? It then becomes, oops, I went to the wrong one. So that becomes k plus, who agrees with that? 2 over k, right?
Yes.
That's right. But now I'm curious. What is this number here equal to? What is that number equal to? Sine of ln 2. Can that be simplified? And that's what someone asked me in class. So sine of ln, yeah?
3 over 4.
3 over 4. Okay, let's see. So that becomes e to the ln of 2. Guys, you got to be careful here. E to the minus ln of 2 all over 2. When e meets ln, we'll get a 2. The minus sign goes there, so that becomes e to the ln of a half, correct? All over 2. And where e meets ln, that becomes 2 minus a half all over 2. 2 minus a half is 3 over 2. Hey, you were right, 3 over 4. So we're going to get k plus 2 over k equals to 3 over 4. And now we go back to grade 1 and we solve for k using the quadratic formula. Boom. There's your 1 mark. Is that correct? Are you happy with that? So you've got to be careful over here. This is important. How you evaluate these things. Okay, and you'll see them time and time again. Yes, question?
So may I ask you, in this situation where you actually have a constant, do you actually want us to firstly change it to like using the
Yes,
definitions or just type it
that's
into a
right.
calculator.
Correct. Yeah, because this is a constant, right? You're right. You're absolutely correct. So it becomes a quadratic. So if you remember, this now becomes k squared plus 2 equal to 3k over 4, and you multiply throughout by 4, you get a quadratic. I don't think it'll factorize, so you use the quadratic formula. So be careful of that. I think this was in the TUT as well. Okay, so I'm just pointing that out to you. And I want you to tackle these questions by yourselves and we can discuss it. What about this one? I just made this up. Right, so how would you simplify cosh of ln x? Can anyone tell me what cosh of ln x is?
Cosh of ln x is.
Yeah, yeah, what is it? Plus
Plus e to ln minus x over 2.
right, but now do you agree with me that this is the same as x plus 1 over x over 2? You agree with that?
Yes.
Yeah,
Yes.
that's right. That's it.
Yes,
So now I put something special over here and I said, well, how do you deal with this 2 over here? So what is sine of 2 ln x? Anyone? Is that not?
Over squared.
Yes, that's ln of x squared. And that now becomes e to the ln of x squared minus e to the minus ln of x squared all over 2. But e to the ln of x squared is x squared minus 1 over x squared. You agreed? All over 2. Do you see that?
No, 40.
Yes, yes, yes.
Where did the 1 over x squared come from? It came from here. That minus goes there and it becomes 1 over x squared. Does that make sense?
Yes.
yes, sir.
And we know when e meets ln, you get that. Okay. You happy with that, guys?
Yes, yes, happy.
Okay. Someone said no in the background. I don't know. But try this out here, this one again. And I just made these questions up because I want you to think about that very carefully. I think we missed the point when we say e to the ln. When e meets ln, it dissolves to get whatever. So this is important. These type of questions are from past exam papers where they expect you to use what we call a quadratic formula to actually solve. So these things are important. So there's limit questions. These are very, very important. I want you to look at them. They're not much, but maybe on Friday, I'll give you a few more questions before the test is on Friday, please. So please go to Moodle, have a look at that carefully, and you'll see that the test is on Friday. Make sure we start preparing for the test and try and get full marks for that. All right. Guys, are there any questions, anything that you want to ask me before we shut this
I
lesson
have
down?
a question.
Yes,
I have a
question?
question.
Sure.
So let's say, okay, an example. I don't know if you want to write it down just for you
I'll
to
write it
see,
down.
maybe.
Yes.
Okay, the limit of x approaching 5,
Yes.
and then it's squared minus 3x minus 10 over
X
x
squared
squared
all
minus
over
over x squared minus 10x plus 25.
plus 25.
Yes. So when you
Correct. So,
simplify, yeah, you don't really
right.
get an answer. So, yeah.
Well, if you do a direct substitution, what do you get?
0
So you're
over
going to get
0.
0 over 0, right? Then the next thing you do is see whether we can factorize this thing. So that's x minus 5 into x plus 2 at the top, correct?
Yes.
And this is x minus 5 squared as x tends to 5. That will cancel one of that. And you're going to get limit of x plus 2 over x minus 5 as x approaches 5, correct?
Yes.
Yes.
But then you see there's a problem there, right? You're going to be dividing by 0. So this becomes undefined, isn't it?
Okay.
Because you got a vertical asymptote at x equal to 5.
So we
Does
don't
that
need
make
to do
sense?
any, so we don't need to do any sign analysis or whatever.
No, because you got a finite number. They see you got no infinity there. So you're dividing by 0, so it's undefined. Yes. Does that make sense to everybody?
Yes.
Yes.
Yes,
Yeah.
yes.
All right. So that's your answer. So firstly, do a direct, then see if you can factorize, and then you're still stuck with something like this, then you know you have an issue. And so that becomes undefined. All right, guys, any other questions? Anything else that you want to ask me? Or are we all good for now?
We are good, 100% sure.
All right, great. So what I'll do then is I will upload this video onto Moodle. Please go through that, but also concentrate on the test on Friday. I want to make sure that we get everybody passes this test. It's online, by the way, so we shouldn't have a problem. I'm also delivering my talk on Friday. I realize I'll show you the program. My talk coincides with our lecture. I'm speaking on some solutions that I found to Einstein's equations. So that'll be very interesting.
Oh,
So
it's very
they want to,
interesting.
yeah, it is. But I'll share the talk with you all. But what I want to do then is either I do a video and cover all the. So my focus on Friday is the test. So I might actually do a video of all the questions that I put there together with more, or I can get my postgraduate student, he's a postdoctoral fellow. His name is Dr. Robert Bugatti, and it'll be nice if he can also maybe talk to you guys and help you out with the test, preparing for the test. I mean, this guy is the most brilliant guy I've met, and you'll see. But the problem with this guy, he will talk and he gets distracted, and suddenly he could leave the lecture after 1 minute and just walk away because his mind is just crazy. So he's done that many times. He's jumped out of a moving car once or twice. He walked into the ocean only to be rescued. He was on the beach sitting and decided one day he's going to walk into the ocean and walked very deep and found himself in very deep water and he had to be rescued. So this is the kind of guy I would like for you to meet because then you know what mathematics actually do to people. But he's a genius. So I'm hoping that he'll be available on Friday uh, to at least do an hour of lessons with you. But if he disappears, then you know he must have jumped off the building or something. I don't know, but let's take that chance and see. But I want you all to prepare for that test, right? So are there any questions, guys? Anything that you want to ask me before we leave? All good. Pengu. Yes. Okay. All right. So, guys, thank you so much for participating in the lesson. I love the answers, and you tried. Now you know the chain rule. Share that with your friends, but share our method with your friends. And I want you to go out there and YouTube chain rule and see how they do it and how we do it. Very, very different. Right. All good, guys. So thank you. And let me stop recording here because the recording becomes too long, then I can't upload, and then it becomes a problem. So let's do that. Right, there we go. Right. So guys, thank you so much, and we'll see you guys on Friday. If it's not me, it'll be Dr. Robert Bugatti, or it'll be a
Sorry,
very
sir.
good video. Yes, question.
Can I have a date
Luli,
for the minor test too?
do you want a?
A date for minor test too.
I will.
Oh, minor test
Major
3, you
test
mean?
two.
Oh,
Major
major
test two.
test
Sorry,
2.
sir.
Major test 2 is being written on the 23rd of May.
23rd of May.
Yeah, 3 weeks time. By then we should be
Thanks.
finished with the syllabus. Yeah. All right. So guys, thank you so much, and we'll let you know exactly what's being tested in major test 3, major test 2. But it's all of this work that we covered today, together with limits, continuity, and a little bit of integration at the end, and we should be done. Yeah. All right. So thank you. Stay safe, and I'll keep you posted. Bye for now, and take care. Okay. Thank you. Bye.